Alright, for the first one we have when two or more waves of the same type meet up at a point, the resultant displacement is the algebraic sum of their individual displacements. Lambda equals to a into x divided by d, the formula of the double slit. So we have pretty much all the values. We need to find the value of the distance between the double slits and the screen, the shortest distance. This is the value of a, but it should be in meters. This is the wavelength given already. And for the fringes, okay, so 1 2 3 4 5 6 7 8. For 8 fringes the distance is 3.2 centimeter. The distance between 8 of the consecutive dark fringes. So the value of x fringe spacing, the distance between two consecutive dark fringes, would be 3.2 divided by 8, which you can then convert into meters. So 0.4 into 10 raised power minus 2 meters. So we get 0.8888 recurring. So the answer in 2SF will be 0.89. So you get 1 mark for writing down the formula. In case you're not able to solve the question, you should be writing at least this one formula. So you'll be getting compensation mark for the formula. And the next thing is, once you have written the formula already, it's very easy to simply insert the values in the formula. And the other one is a wave y. Okay, so pink one is wave x. So x is pink and the other one is y. State the amplitude of the wave x. Probably the easiest one. Amplitude means the maximum displacement from mean position. Both waves have frequency 16 Hertz. Determine the speed of wave x. So this wavelength would be length of one wave cycle 0.4. So 64 divided by 10 would be 6.4 meter per second. And matter of fact, we can also directly answer what is the phase difference between these two whenever the two waves are mirror images of each other, like vertically flipped. One wave is like this and the other wave is exactly opposite. Irrespective of the amplitude, then the two waves have a phase difference of 180, and it remains 180 throughout because they have the same frequency. Okay, so we have two waves, they superpose means they combine, they overlap, and they form a resultant wave. On figure 3.2, sketch the variation of displacement of the resultant wave with distance from A at the instant shown at instead of time shown in figure 3.1. Okay, so distance from A. So for this one, uh, at this distance of 0, the displacement of both of them were 0. So the displacement of the resultant wave would also be 0. So this is the starting point. And at zero point 0.1, amplitude of first one is 10, of second one is minus 20. So the resultant would be 10 plus minus 20, which is minus 10. So over here, the displacement is minus 10. Let's take a look at 0 0.2. 0 plus 0. Once again 0. Let's take a look at my 0 0.3. At 0 0.3, this is 20 and the other displacement is 10. So 20 plus minus 10 would be 10. And then at 0 0.4, it would be 0. 0 plus 0 is 0. And then the same pattern is repeated. You can easily guess the pattern. They have constant phase difference, so the pattern remains the same. If you trace one wave cycle, the other one would be very easy. You simply need to follow the same pattern. Intensity of the wave x is Ix. The intensity of the wave, the other wave, is Iy. Calculate the ratio of the intensities. Simple formula: the ratios of intensities is equal to the ratio of the square of the amplitudes. That's it. We studied that formula many times during the normal okay. Now I simply need to insert the value of Ax. So the amplitude of x was 10 and the other one was 20. So 10 and 20. So the first one would be square of 10 divided by the other one would be square of 20. You simply write it on the calculator. 10 square divided by 20 square would be 100 divided by 400, which is 1 divided by 4, and we write in decimal 0.25. Okay, so here we have the first one. State-wise, sound waves cannot be polarized. A plane polarized light is incident on a polarizing filter. So the light wave was polarized already. So this is a polarized light, and now this filter will be known as analyzer. Okay. The filter is now rotated through 360 degrees about the direction of. We need to draw the graph of the intensity with respect to the angle. Okay, now this one is a little bit tricky because now they have placed the second analyzer, and the second analyzer in this question, the second analyzer, the analyzer or the second polarizer is rotated through different angles. So let me draw a table. We can use those values in the table to plot the graph. We say when alpha is 0, when alpha is 0 degrees, what is the actual angle of this analyzer with respect to the previous filter? 90. So when alpha is 0, the angle theta is 90. So cos 90 will be 0. I will also be 0. Now if we rotate this by 90 degrees, so now the value of alpha becomes 90. So I'll rotate it right in front of you. This filter is rotated 90 degrees. It looks something like this. So if you rotate it 90 degrees, the angle alpha is obviously 90. But what is the angle of this analyzer with respect to the filter or polarizer? Now it is 0. You see, both are vertical now. So when alpha is 90, the angle theta or the angle of the second filter with respect to the first one becomes 0. Hence cos 0 is 1 and square of 1 is 1, and I will be maximum, which is I naught. Third case, when alpha is 180, means you rotate it further 90 degrees. Now it will look something like this. Check it out. So in this case again, the actual angle of this second filter with respect to the first one is 90. So when alpha was 180, this is again perpendicular. You can call it 270 or just 90. I mean, it is again perpendicular. So cos 90 would be once again 0 and I naught would be 0 once again. You rotate it further 90, this angle becomes 270 and these two become parallel. The slits will be, the second filter will once again become parallel to the first one. It will look something like this. So when you rotate it by 270, they once again become parallel. So when alpha is 270, the angle between these two is 0. So cos 0 is 1. Even if it's 180, we have to take square anyway, so square of minus 1 would still be 1. So technically in this case the second polarizer is flipped, so the actual angle is 180, but cos 180 is minus 1, but we have to take square of minus 1, so it will once again be positive, and this one would be I naught. So we draw mark here, then we can follow the trend, and exactly in the middle at 45 the intensity is always half of the maximum. So the graph will be a sine wave that would look something like this. Alright, now for the last one, alpha is 20, which means what should be the angle theta? If alpha is 20, then the angle theta means the angle of the polarizer, second polarizer with respect to the first one would be 70. Because there was always a difference of 90 between these two. Check, look. So I can draw over here. Let's say this is the first polarizer, and initially the second polarizer was placed like this. And this is the position when alpha is 0, but the angle theta means the angle of the second polarizer with respect to the first one is 90, because the second one is perpendicular to the first one. Now if I rotate it by 20 degrees, if I rotate it by 20 degrees, now the angle between these two with respect to each other will become 70. So I over I naught, they will be related by this formula, cos square theta. I equals to I naught cos square theta. So I over I naught will simply be equal to cos square of theta, and theta is 70. So cos square 70 equals to A. What was the amplitude initial? So the new amplitude we don't know, but the old amplitude A naught. A naught means the old amplitude. This one was A naught square. So the new amplitude A square equals to A naught square cos square 70. Then you can take square root on both sides. It will be A naught times cos 70. Now we simply need to find value of cos 70. Cos 70 is 0.34 times A naught is already there. So 0.34 is indeed the answer.